Network Plus Series, Network Devices Part 2. Well, I feel pretty confident that you're really going to enjoy this nugget. We're going to continue our discussion of network devices, but this time we're going to get into some specialty devices and some of the extremely cool features about a Layer 2 and Layer 3 switch. As a matter of fact, to show you some of the specialties of a network device, I'm going to spend most of my time in the Cisco Adaptive Security Appliance, which actually provides all of the advanced features and extra features all integrated into one device. So without further ado, let's look at our objectives for this nugget. In Network Devices Part 2, we're going to look at some of the specialty appliances, the specialty devices that you can have in a networked environment. And instead of looking at all of these individually, content security and IDS, IPS and proxy server, quality of service, DNS and DHCP, we're going to look at the Cisco ASA, which actually has all of these features and more built into one integrated converged appliance. It's a fantastic product. And again, this is not a Cisco specific exam, but this is a great networking device to use as kind of a prototypical way to learn some of these different technologies. Then we'll talk about network load balancing. It's one of the other prerequisites for this particular domain that we're talking about, network devices. And then we'll look at some advanced switch features. We'll return to the concept of VLANs. We'll look at private VLANs, which are an advanced extension to VLANs. We'll talk about spanning tree protocol, power over Ethernet, trunking, port mirroring, and 802.1x port authentication. Now the first device, this first specialty appliance I want to talk about is content security. And historically, content security was provided by a software application that ran on maybe a Unix or a Linux or a Windows server. And this falls into the category of proxy services because the proxy server or the content server stands between the client that's using email or internet web access or other programs to get access to a public untrusted network. So what these new content security appliances, and what we have here is a Cisco Iron Port appliance. Up here you see this is called a CSC SSM, a Cisco Security Content modular device that actually goes into the adaptive security appliance I'm going to show you here in a minute. But what these tools provide are updatable, up-to-the-minute antivirus protection to protect against viruses and worms and other malware, anti-spyware and adware that can pop up on your web browser, anti-spam tools to prevent email spam from getting into the organization or getting to your Exchange server, for example. There's anti-phishing. Phishing is what's done through email, through hypertext links in an email message or other nefarious email that tries to direct you to some website or provide you with some input where you're going to offer up some of your own personal information so that identity theft can occur. Also, these content security modules or devices have automatic updates with the vendor, whether it be Cisco or maybe a partnership with Trend Micro or McAfee or Symantec. They've got central administration, and the central administration is going to provide things like network admission control from Cisco or NAP from Microsoft, where you can work with the end user devices, the laptops and the workstations and the handheld devices, to make sure that their security posture is up to date, to make sure that their antivirus, anti-spyware, anti-spam software is updated. You also get real-time protection for web access, for mail transfers, for file transfers with FTP. These tools typically do deep packet inspection with the FTP protocol, the SMTP protocol, the HTTP protocol for the World Wide Web. Right here is where we get our proxy services, in the sense that it's going to stand between the client and the untrusted network by providing URL filtering capabilities. In other words, only allowing the client to connect to certain websites and filter out other sites like adult sites, online gambling sites, sports sites, YouTube, MySpace, Twitter, those kind of things. You can filter them out. And you can do it on a scheduled basis, on a category basis. You can actually cache first, which in other words you're going to store these in memory on the device, the web pages that they can allow, and you can apply your filtering there. The caching also provides a service as a proxy to increase performance and cut down on bandwidth between your site and the internet provider, because if you're caching web pages that end users access on a daily basis, you don't have to go retrieve or get those web pages up from the internet and go through your provider. So caching is a performance benefit as well. And then email content filtering, using tools to filter or what we call clean out your email messages so that you're only getting the kind of email you want to get. Now again, the specialty device or the specialty appliance is the way to go now, but we still have services. For example, Microsoft has an IaaS server, and for example, Microsoft's Exchange mail service, Exchange 2007, has what's called a Edge Transport server, and this Edge Transport server provides a lot of the features of content security. You can sit out in your demilitarized zone in your DMZ and do what's called message hygiene. Message hygiene is the same thing as kind of cleaning out. Message hygiene is going to provide a lot of the same types of services, anti-spam, antivirus, things like that, for SMTP and HTTP content. So again, content security can be provided by specialty appliances, or it can be provided by specialty services that run on network operating systems like Linux and Windows 2008. Another specialty device or a special appliance on the network would be an IDS, intrusion detection system, and or IPS, intrusion prevention system. And these devices typically nowadays come into, they are these 1 RU or 1 rack unit, 1 RU or 2 RU sensors. Now these sensors can be placed throughout the organization. These sensors also could be modular added to a router or added to a high-end switch. But the goal of these IDS or IPS sensors is to detect traffic, to analyze the traffic, to send alerts to management stations and administrators either through texting or email messages, or to consoles or to web-based management stations. They also log using syslog protocol or the SDEE protocol, and then to react. And the action they take can be based on whether they're IDS or IPS. In other words, intrusion detection is going to be more reactive. You're going to take a copy of the traffic from a switch and mirror it on that port to a IDS sensor device, and then you can react to that traffic, analyze that traffic, monitor, report, and log on the traffic. Intrusion prevention, though, is more proactive. So IDS, this is a D here, IDS operates in what's called promiscuous mode, where let's say this is a switch, just for the sake of argument. Let's say this is a multi-layer switch. I can have a trunk port going from this switch to a sensor, and I can be mirroring selected traffic from this switch to the IDS sensor, and this sensor is operating in promiscuous mode, taking copies of that traffic, and of course it's performing all these actions: detection, analysis, alerting, logging, and reacting to the traffic. The reactions could be sending messages back to devices to shut down ports, for example, or block with access control lists. Or a sensor can be an inline intrusion prevention system. And basically, an IPS has the capabilities not only to detect, but also to proactively prevent misuse and the abuse of unauthorized access to network resources. So these can actually respond to what we call day zero attacks. Now, you've got three main categories of intrusion detection, intrusion prevention. You have signature-based, where the sensor itself will have a huge database of signatures. In other words, these are definitions that are built by network engineers and security engineers that define the characteristics of different type of attacks that are out there. Worm attacks, virus attacks, Trojan horse attacks. And so you've got a signature database that you're going to upload on a regular basis to allow you to have intrusion detection, intrusion prevention. Anomaly-based is when you're going to take your sensor and it's going to basically monitor the traffic and create a KB, or a knowledge base. It's going to create a baseline of normal traffic called the knowledge base. And then any anomalies to that baseline or that knowledge base are going to appear to be malicious traffic or certain types of attacks on your network. The third kind is policy-based, and that's where you'll start kind of with a blank slate. You'll analyze your network and the types of applications and protocols and services that you use on your network and the traffic that's coming into your network and out of your network, and based on that you will build a policy and you'll design your software in your sensor around that policy. That's a much more rigorous approach, but it can also be the most effective approach. Signature-based, anomaly-based, policy-based. So you've got three types of IDS, IPS, and then of course three modes: promiscuous IDS mode and inline IPS mode. What is the main purpose of these special devices on your network? To mitigate against reconnaissance attacks, for example, like port scans and ping sweeps on your network. People trying to map out your IP addressing and map out to see what TCP and UDP ports are being used. To isolate malformed packets or invalid packets or malicious packets that are coming in or out of your network. Denial of service attacks and distributed denial of service attacks. Attacks that are meant to be targeting a router or a server or some other network device in order to overwhelm its memory buffers or overwhelm its processor or fill up disk space. And of course, to look for abuse in common application layer protocols and services like HTTP, FTP, ICMP, ARP, SMTP, for example, among many others. Intrusion detection systems, intrusion prevention systems. Well, I failed to mention in the introduction the most important specialty appliance of all. That's the firewall appliance. I was going to talk about it in Network Devices Part 1, and then I put it in Part 2 and forgot to put it in the intro. But that being said, let's talk about the firewall. And first of all, I'm going to go to my configuration. This is an ASA. This is an adaptive security appliance, and it is an integrated device that provides a bunch of different services. It provides, as a matter of fact, it can, if you have the right module in the ASA, it can provide content services. It can provide intrusion detection, intrusion prevention services. Now, this ASA doesn't have a content security module in it, nor does it have an IDS IPS module in it. So I went ahead and talked about those separately. But if I go to configuration here, you can see this device has got several interfaces. It has an outside interface with a security level of 0, which means this is the most untrusted network. The outside interface connects to a perimeter router that goes to the ISP or the provider. The inside network is the most trusted network with a security level of 100. Then my other interfaces can be anywhere in between 0 and 100. I could make Ethernet 02, for example. I could make this into a DMZ, or a demilitarized zone, where I put a bunch of content servers out there like SMTP servers, web servers, SharePoint servers. Give it a security level of 50, enable it, and give it an IP address of, let's say, 172.30.1.10. How's that? And click on OK. And so now I've got a DMZ interface. And of course, this is halfway in between the untrusted 0 and the most trusted 100. And there is by default behavior that can happen between these particular interfaces, and those are called access lists or access rules. So basically on your firewall device, you're going to have at least one inside interface and at least an outside interface, and possibly a DMZ. This makes this a three-armed firewall. And by default, I'm going to allow all traffic generated from the inside of my network to go ahead and go to the outside network or the DMZ. However, by default, traffic from the outside can't go to the DMZ or the inside unless I explicitly permit it with an access control list. Now let's go to this little firewall option here. And when I do, this shows me the interfaces that I have and the rules that are applied to these by default. And my firewall allows me to do things like network address translation, to translate private IP addresses on the inside to public valid IP addresses on the outside. Another service that my particular specialty appliance can do is provide virtual private networks, an IPsec VPN between this headquarters and a remote branch office or a regional office, or remote access VPNs to remote users and teleworkers, people using laptops and handheld devices and workstations from their homes. Now, some other services that can be provided are things like DHCP services as well. So I can dynamically allocate DHCP information and IP addresses and client information to remote access clients, for example. Or I can have a domain name system service as well, DNS. So a specialty appliance like a firewall or this adaptive security appliance can also provide domain name system services. It can also provide DHCP services, allocating IP addresses and subnet masks and over 200 other DHCP options as well. It can provide AAA services, authentication, authorization, and accounting using some back-end Radius server or TACAC server. If I go to the advanced area down here, it can provide proxy services, and my ASA here can function as an email proxy, getting some of those basic content services that we talked about earlier. It can also service as a web proxy. It can also service as an authentication proxy. Here we go under device management. I can come over here and I can say, look, I want this to be a AAA proxy server where I can actually do authentication of users who want to access through this device. I can provide certificate services. So this can be a public key infrastructure server. Again, as I mentioned, it can be a DHCP server or a DHCP relay. It can be a DNS client or a dynamic DNS server. And again, other advanced things, HTTP redirect. This would be something that would be a web proxy service, and I could redirect web pages to some vendor partner like a WebSense server or a Web Smart Filter server. So again, what we're seeing here is that these specialty appliances, these specialty devices, provide a wide range of services all integrated into one device. And I'm accessing this device right now through the Cisco Adaptive Security Appliance Security Device Manager, which provides me all types of dashboards and configurable functionality to configure and monitor this particular device. So specialized network devices, and I'd say the king of all of those devices is Cisco's Adaptive Security Appliance. In this CompTIA Network Plus section on network devices, they also want you to understand the concept of network load balancing, which is pretty important in networking. The concept of load balancing is to basically spread the work or the traffic or the load between two or more systems. Now, these systems can be servers like we see here. They could be network appliances. They could be network links. They could be load balancing between multiple CPUs, multiple hard drives. The bottom line is you're trying to provide redundancy or fault tolerance. So if one device goes down, the other one can take over, kind of as a hot standby. Or it can be to optimize utilization and throughput and response time by having multiple devices responding, for example, to these clients down here at workstations, laptops, and remote clients. Now, the balancing service can be provided by the network operating system. For example, Windows 2003, 2008 has a networking load balancing feature. It can be provided in lieu of a clustering service, for example, or it can be provided by the multi-layer switch. Multi-layer switches often provide network load balancing in their switch ports. And they can do it very quickly because a multi-layer switch has this kind of built-in ASIC hardware, ASIC. And we'll just assume this is a multi-layer switch here. It has this ASIC hardware, application-specific integrated circuit, that can provide this load balancing feature among the servers that are plugged into it or the devices that are plugged into it, among many other features as well. Now obviously service providers are going to do this, but what we would do here for an enterprise organization is this would be, let's say, out in a demilitarized zone. In a DMZ, you're going to have some content servers, some web servers, some FTP servers, maybe some SharePoint servers, email servers, for example, some Exchange 2007 front-end servers. And the bottom line is these are being represented by kind of a virtual server. So this virtual server may have an IP address of, let's say, 157.54.1.10, and all of these clients out here, this is a cloud of some network, it could be the internet, are accessing this virtual server. But what they're really doing is this IP address is being mapped to two real servers connected to a switch that maybe are at .9 and .8. And of course there could be some network address translation occurring here as well. So the load is actually going to this virtualized server, and it's being load balanced between these two servers. And the load balancing could be kind of a round robin thing where each packet kind of in a round robin fashion goes back and forth, or you can use more elaborate policy to determine which one of these devices is getting the load balancing. And again, this load balancing can also be a redundancy scenario, so that if one of these servers or services goes down, and again I'm saying server, this could be any network appliance, if it goes down, the other device can assume the load, hypothetically speaking or theoretically. Now these load balancers can do a wide variety of different features. Okay, they can manage the load asymmetrically. In other words, this particular server could handle 60% of the load, and this particular server 40% of the load. You can also offload to these front-end load balance servers things like encryption, which uses up a lot of processor. Okay, so these front-end servers could handle encryption. They could handle some of the things that a content server does, like antivirus, anti-spyware, we call hygiene services. It can compress web pages, HTTP. It can cache the web pages. It can do buffering. It can provide security. It could even provide firewall services. So when we look at network load balancing, the bottom line is this. You're spreading the load between two or more redundant systems, but typically these servers, which again are virtualized and represented as a single server, actually are going to be proxies for some back-end, possibly database servers or other content servers. So it provides kind of this extra layer between the front-end services to offload some things from back-end database servers, mail servers, and content servers. And it can also provide security as well, because you can implement security mechanisms on these load balance servers and get some protection for your back-end servers, like your database servers or your web server farm or your SharePoint server farm. Network load balancing. Finally, we're going to look at some advanced switched features, and if you're not taking notes, right now might be a good time to do that. I'm not going to write out everything I'm going to tell you here as I go through and define different technologies that apply to switches and multi-layer switches. These are advanced features And again, there's many more advanced features besides this, but these are advanced features besides just basically switching packets from one inbound port to an outbound port. Now, we've already defined VLANs, and you know that a VLAN or a virtual LAN is basically a group of end stations that have a common set of requirements, and it's independent of their physical location. So they can be grouped up based on a project, based on their business unit, their roles. Okay, so a VLAN has the same attribute as a physical local area network or a subnet, with the exception that it lets you group these stations up regardless of where they're physically located. A VLAN also lets us group up ports on a switch, and that allows us to limit flooding, unicast traffic flooding, multicast traffic flooding, and broadcast traffic flooding. And we understand that I can separate ports, for example, into their own VLANs, and they will be segmented or separated from the other VLANs, and I have to have some type of router, either another dedicated router or some type of route processor or route module in this chassis to provide layer 3 routing services. That is, unless it's a multi-layer switch. If it's a multi-layer switch, we know it's going to function at data link layer 2 and network layer 3, so it has the route processing built into it. Now, a PVLAN is a private VLAN, and basically what a private VLAN does is this. Maybe I've got 3 VLANs. I've got VLAN 10 for the marketing department, VLAN 20 for the accounting department, and VLAN 30 for the IT department. If I wanted to, within the IT VLAN, I could actually take different servers and workstations within VLAN 30 here, and I could further segment these up into their own private VLANs. So I can have basically a VLAN within a VLAN. Now, when would I really do this? Well, think about this. If I've got a demilitarized zone, which is basically created by a firewall, right? Firewall creates a DMZ. In that firewall, or in that DMZ, I've got several servers. Let's say they're Windows 2003 servers, and they're running web services, application services, other things. What I might want to do is this. With all of these servers in the same VLAN, we'll say these are in VLAN 30, in the DMZ, I can use the firewall, yes, to segment all of these servers from the inside of my network and the outside, so I can get firewall protection. But within this VLAN 30 and all these servers, I may want to have additional protection between certain servers. Because remember, network operating systems like Windows have trust relationships between servers in the same domain. And so attackers out here can literally take advantage of and attack this trust relationship between these servers. So I can use private VLANs to further segment a VLAN so like only a certain server can talk to another server. Okay, so it's basically a VLAN within a VLAN. You create private VLANs inside of those broadcast domains. Now, a second advanced feature, which is a basic feature of switching, is the spanning tree protocol. And spanning tree protocol has one service and one primary function only, and that is what we call loop prevention. I'm just going to type loop prevent here. I'm going to go ahead and clean up my screen real quick. Let's talk about spanning tree protocol, or STP, here. And let's say that this is in a multi-floor building. And this is the second floor. And this is the first floor. And this is the third floor up here. And let's say that the core of my office is on the second floor. So the core of my switched fabric of my organization is these 4 multi-layer switches that have these redundant connections between them. And then also up here on the third floor, I have this switch that's kind of servicing the entire third floor, all of the VLANs, all of the other access layer switches and other devices. And I've got this switch down here on the first floor that's servicing, let's say, the main foyer of my office, maybe a couple of conference rooms, the security office, those types of things as they come into the building. So, and I've got redundant connectivity from this switch or multi-layer switch to these distribution switches. And what happens is, because of all of these different redundant paths, in a switched environment, you have a high probability of loops being caused. And remember, in the IP protocol, the IP header has a field in there called the TTL. And the TTL field will be something that's, say, like 32. And as each one of these IP packets crosses a router, that TTL value gets decremented from 32 down to 31, all the way down till it gets to the final router in the topology when it gets to 0. And 0 is basically means it's going to drop the packet. The time to live field is in the IP header specifically to prevent those loops from occurring. The problem is, in the spanning tree protocol, this is a layer 2 function. Remember, this is switches. The frame does not have a time to live field in it. The Ethernet frame, for example. So we need to use a protocol like spanning tree protocol to make sure that loops aren't created. So what happens is, spanning tree protocol very rapidly uses bridge protocol data units that are shared among all of these different devices. And they will use a spanning tree protocol to determine what the root bridge is, or the best bridge, and then the best path to that bridge, and it will actually disable ports automatically to prevent loops from occurring on the network. So spanning tree protocol is a layer 2 loop prevention mechanism for the underlying switch fabric of your environment. Now, this particular switch up here may have a modular port, or it may have special ports on it that allow you to connect to telephones. Okay? So I'm just going to make this a telephone. Not just an ordinary telephone, but a IP telephone or IP telephony. Okay? Otherwise known as voice over IP. And so these telephones, these are not going to be plugged into a wall. Okay? If you've seen these kinds of IP phones in your organization, they don't have power cables coming out of them going into an adapter and then plugging into the wall. They get their power through the actual Ethernet cable. So they're using unused wires, because by the way, only 4 of those wires are being used, 4 out of the 8, so they use other wires of those 8 wires to get power. So they're getting power over Ethernet. So they're using extra wires in the category 6 cable, for example, going to the switch. But the switch ports themselves have to support power over Ethernet. And so lots of your modern switches either support them in the actual chassis themselves, or they'll have modular units you can pop in there that support power over Ethernet. As a matter of fact, that adaptive security appliance that I just talked to you about also has the ability to have a couple of power over Ethernet ports on it, so that you can plug some IP phones into it. So power over Ethernet is used. It's an advanced switch feature to support IP phones and other devices that want to get power through the Ethernet cable, as opposed to through the AC-DC circuit on a wall. Now, if you look at these switches over here, we know that with switches we can create VLANs. I could have a VLAN on the first floor. I could have a VLAN on the second floor. I could have a VLAN on the third floor. But I may want to take a couple of workstations on the first floor and a whole department on the second floor and several systems on the third floor and put them all in their own VLAN. Okay? Maybe I want to put them into Project X VLAN. Okay? Well, if I've got several devices here and a department here and several devices here in the same VLAN, how do these switches know, as the frames move from switch to switch, what belongs to what VLAN? And that's where trunking comes in. These frames, as they leave the interface, are colored with a 802.1q tag. And they tag what VLAN they belong with. So you create these trunks from switch to switch, And these trunks carry multiple VLAN information. Okay, so all of the VLAN information is carried between all of these switches that are trunked together, so that you can have devices in different VLANs, and as the frames move, they're tagged with the VLAN identifier, and the trunked switches can provide this VLAN and private VLAN functionality throughout the entire organization. Now, another advanced feature of a switch or a multi-layer switch is to do what's called port mirroring. So you can actually take one of your ports or multiple ports, and you can take traffic that is traversing this switch coming from either down level switches or independent devices, and you can mirror that traffic over here to an IDS IPS device, or it could be a IDS IPS running on a Cisco router, for example, or other router. So you're mirroring the traffic over here to your intrusion detection system so that the traffic can be analyzed, it can be inspected, and it can be acted upon. And so port mirroring uses special protocols, and again, this mirroring can actually filter out certain types of traffic at layer 2, and depending upon the device, even at layer 3, and mirror that traffic over to the particular device so you can do your analysis, you can do your detection, you can do your inspection, and then actions can be taken accordingly. Now you can also mirror from a switch port to a management station. And this can be done for a wide variety of reasons too. For example, you can do it to do analysis. Or you could be running on this particular management station a packet sniffer or an analysis tool, let's say like Wireshark. And you can use this mirrored traffic coming to your station to do network analysis, network monitoring, network management. Finally, the last thing is 802.1x, and I've already alluded to this. This is what we call port-based authentication. Okay? Port-based authentication. And what's going on here is this. We can actually control at the port level which devices can actually connect to our network. It's one thing to have a user come in and connect their laptop into a port in a cubicle and be confronted with some type of password input mechanism, some access control that asks for their username and their password and their credentials. However, port authentication goes even further. It will actually look at the MAC address of the network interface card that's integrated, or the PCMCIA card, or whatever layer 2 MAC address is. It will look at that MAC address and it will ask, and let's just get rid of this. Let's say this is a back-end AAA server that's using a protocol, let's say the Radius authentication protocol. So this device right here can be this is the supplicant. Okay, the client is begging to get onto the network. It plugs into a port and it tries to connect to this particular switch. And there's a negotiation protocol that goes on and some questions being asked by the switch. Now this switch is going to look at the MAC address of this station, and it's going to go over here. This is the authenticator. The authenticator goes to the authenticating server, which is the AAA server, and uses the Radius protocol. So the Radius protocol is being used right here. And this particular server will either look in its own database, or it will talk to some back-end database like Microsoft's Active Directory using, let's say, maybe the Kerberos security protocol, or some other back-end database, or its own database to say, do I have this MAC address in my database? And is this device legal and authenticated and authorized on my network? It will send the information back, and then this particular device will allow it or not allow it. Now you can do other policies as well. You can say, okay, here's what we're going to do. We'll authenticate this particular laptop's MAC address, but we're going to further authorize what this laptop and the user on this laptop can do on our network. And this can also be stored in policies back on the AAA server. So when this device is saying to the authenticator, which is our switch here, yes, go ahead and allow this device on, it can also provide what's called authorization information that says these are the protocols and services, these are the things you can do on the network. You can even configure this switch to say, you know what, if this device is not allowed onto the network, we're going to send them to a special VLAN, and this special VLAN connects from this switch to a router that gets them out to the internet. In other words, if this is somebody bringing a laptop, let's say, into a conference room or the foyer of a enterprise organization, they're not authenticated and authorized to get onto our corporate local area network. But we can say, well, as a backup policy, we'll redirect them to what we call a private VLAN or a special VLAN, which just allows them to connect to this router to get out to the internet, so they can do web surfing, for example, or they can go do their online banking or things like that. So this 802.1x protocol actually operates on top of Ethernet, wired Ethernet. It can also sit on top of wireless LANs. So you could have a .1x implementation in your organization, and it could apply to your wired network and or your wireless network as well. And you can further add to .1x by using extensible authentication protocols, which provide you with a wide variety of different mechanisms for authenticating those users and those systems. For example, you could use certificates in a public key infrastructure. Well, as I was producing this particular nugget and I was doing the intrusion detection system, intrusion prevention system, I realized that I need to talk about firewall appliances that I was going to cover in part 1. I didn't have this in the introduction, but obviously we talked about content security, talked about IDS and IPS, and of course the firewall appliance, and we looked at the adaptive security appliance and some of the features on this ASA, like proxy services and quality of service, DNS and DHCP. We talked about network load balancing, an important high availability and redundancy feature for networking devices, and finally some advanced switch features including VLANs, private VLANs, spanning tree protocol, power over Ethernet, trunking, port mirroring, and 802.1x. I hope this CBT Nugget has been informative for you. I'm going to thank you for viewing.